Khaled.
And I'm Chris Kappelmeier.
And we're here today to have an interview with Sir Isaac Newton and his history on how he created Newton's laws of motion. So tonight we have a very special guest coming on the show. His name is Sir Isaac Newton.
He's developed some of the major key factors in developing our laws of motion.
Isaac, could you please join us on the stage? Hi, Isaac. How are you doing tonight?
Pretty well, Susan. It's great to be here. Thank you for having me, and Chris.
Thank you. So, Isaac, can you tell us about some of your laws, maybe starting off with your first?
Well, the first law of motion is actually very simple. An object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. So that's pretty easy to understand, right?
Yeah. Well, could you give us a few examples on how that might actually work?
Well, yeah, let's go back to the clip camera and see what's going on.
Isaac, those are some pretty interesting examples. Could you elaborate to us what is actually going on in them?
I would love to. In the first example, when water bottles are left on top of a car and the driver speeds away, the cups will want to stay at rest, so it will slide off the back when the car pulls away. In the second example, when the car is moving and then it suddenly stops, the passengers inside the car will want to continue moving at that speed, so that's why they continue moving at that speed, and then they hit their necks back on the car.
Good thing they were wearing seatbelts.
Good thing.
Now tell us what happens in the last example.
Okay, well, in the last example, we have a ball sitting on the floor, and the ball represents an inactive object because it is not moving. It will not move unless it is bumped by something, like an unbalanced force. And that makes sense. Like, a ball is not really going to move by itself. So when somebody kicks it, which is the force, it will move. So it's basically really simple.
So, Isaac, tell us about your second law of motion.
Well, my second law of motion is also very simple. It is represented by the equation F equals ma, which stands for force equals mass times acceleration. The strength of a force is equal to the amount of mass involved multiplied by any acceleration applied to it. Now, do you guys understand that?
Not exactly. Could you show us a few more examples?
Okay, let's go back to the camera and we can do that.
So in this example, the car has a greater force exerted on Isaac so that when Isaac is walking towards it, he gets pushed back. So the next thing you want to talk about is Isaac's life. So Isaac, is it true that you were bullied as a child?
Yes, it was. It is very true. I was not a very smart student, so I was bullied.
And didn't that inspire you to create your second law of motion?
Yes, it did.
So we actually have some footage of the apple falling next to you, and there is some examples of your second law of motion in there as well.
Oh, really?
Eureka!
Oh my god, so dumb.
Guys, look at this apple. I have to tell you something that happened to me.
Oh my
today.
god, no one cares
You're
Isaac
so
about your stupid
dumb.
apple.
So in the example with you being bullied, the reason why you get pushed over is because two people have a greater force than one person does. Therefore, that is the reason why you fall over. Wow, those are some pretty good examples. Now, I understand that we have one more law to go through. Can you explain to us that one?
Okay, Caesar. The last one is really the simplest of the three. For every action, there is an equal and opposite reaction.
One, two, three.
I don't get it.
Okay, well, Caesar will explain the balloon example first.
So basically what happens with the example of the balloon is that the air inside of it pushes out of the neck of the balloon, making the balloon go in an opposite direction.
Yes, that's exactly right. Good job.
Wow, I can't believe we went through all three laws of motion.
I know, it has been a blast. Thank you.
Whoa, look at the time!
What, it's 5 minutes up?
Yeah!
Well, thank you so much for having me. Thank you for having me.
Yes, thank you so much for coming, Isaac.
You're welcome. It's been fun.
Yes. Now, next week, we're going to have a special with Sandra Bullock and all the special movies that she's been in.
Okay, sorry. Is it, I don't know, is it?
Yeah.
Okay. Alright. 1, 2, 3, go.
Hi, I'm Kara Winstein.
Okay, go. Who's that? David.
Ready? Yeah.
What have I discovered here?
Are you still talking about that apple, Isaac? Shut up. Please come join us. Alright.
Caesar, how are you?
I'm doing well.
So Isaac, can you tell us about your laws? Maybe starting off with your first.
Well, yeah, the first law of mass or whatever, whatever.
Of whatever.
Our first law.
Tonight on our show, we're going to have a very special guest named Sir Isaac Newton. He developed some of the greatest laws of motion, and here he is.
No, you can start.
Yeah, do that.
I laughed.
How are you both found equally?
So tonight on our show, we're going to have a very special guest named Sir Isaac Newton.
He's probably one of the most key factors in how to develop physics. Okay. Alright, go. Alright, get up and sit down. Am I doing something wrong? Get up. What am I doing? Really into character right now. Go! Dylan, I'm gonna punch you. If this is again. Get up. Okay.
Can I look ahead
What are you doing tonight?
Pretty well. How are you, Caesar Salad?
Good. Why didn't you say the whole thing?
Good, how are you,
Good.
Caesar Salad?
So Isaac, how are you doing today?
Good. How are you, Caesar?
Good.
Can you tell us about your laws? Maybe start off with your first one.
Well, my first law of conservation of energy. What are we doing?
So my first law, blah, blah, blah.
I can't